At this time, we'd like to invite LOOMIA Technologies to the stage.
Hello, everyone. I'm Ezgi Uchar from LOOMIA Technologies, and I'm really excited to be here as a part of NASA iTech. I passed through two of our samples that you can probably see if you're a part of the jury. One of them is a really flat lighting sample that we have, and the other one is a heating, lighting, and sensing sample that demonstrates our technology. So hopefully you will enjoy them while waiting for Okay, good? Okay. Well, we are in contact with textiles for up to 98.
Robin, can you reset the time, please?
Okay. Okay, I'm starting over. We're in contact with textiles for up to 98% of our lives, and now they're starting to become intelligent. When I say textiles, people usually think about garments and apparel. And when I say smart textiles or e-textiles, people usually start thinking about wearable technology or smart garments. At LOOMIA, we think that there is a much bigger potential for e-textiles or smart textiles than just wearables. We think when we think about e-textiles, we think about automotive seats that are intelligent enough that they will understand that the driver is falling asleep and then it will wake them up. Or medical devices that are not cold and hard, but comfortable and soft for the patients. Or outdoor gear that are foldable and thin and light enough, but can also bring technologies such as heating or safety lighting into the user. At LOOMIA, we design and manufacture technologies that bring functionality into soft goods. We're a B2B company that creates a soft circuit system called the LOOMIA electronic layer, or the LEL for short, that I will be referring to it throughout the presentation, that can be designed to heat, light, and sense. So you can think about the LEL as a circuit board, but it's not hard and pointy like a circuit board, but it's soft and flexible like a textile. So it acts as a circuit, but it's soft, flexible, and drapable like a textile. We customize the design and functionality of the LEL for our B2B customers. The main functionalities that we provide right now are heating, data and power cables, lighting, and soft sensor and antenna applications. Of course, we're not the only e-textile company in the field, but we believe that we add a tremendous value by solving some of the biggest problems in e-textiles that we have identified. Some of these are form factor, robustness of a hard-soft connection, integration ease into a textile supply chain, full solution that can be plug and play for textile or other brand companies, performance of the layer, and the scalability of the e-textile product. Looking at the form factor of our LEL, it can be 4.15 to 340 times lighter than a hard wire equivalent of the same length. It can also be completely wire-free, but we can also design it to work along with wires depending on the requirements of the product. Talking about the soft and hard barrier that I was saying it's one of the biggest challenges, we actually solve this challenge with our interconnect system that is robust, reliable, and efficient, and can be washed up to 50 cycles within AETCC 135 washability standard. Also, we create a system that is very easy to integrate into textile supply chains. Normally, even if you don't know anything about electronics or textiles, you can guess that electronics wouldn't necessarily go with the production of textiles. But our circuit is actually sewable and bondable with regular cut and sew facility machinery. So our customers doesn't need to integrate new machinery or bring in new labor to integrate our system into their products. We create a fully insulated and fully functional plug-and-play system that can directly be sewn into a product and start working. We have a modular approach to our system that includes a soft layer, which is our patented technology, integrated components that can integrate onto our soft layer, such as LEDs or hard sensors, and interconnect that is creating the soft and hard connection and also has the brains of the circuit, an adapter cable for power and the power source of our customers' needs. Because we take a modular approach, we can also sell only components and allow our customers to integrate their own components or power source into the system. Looking at the performance of our products, we always try to get the highest performance for the necessary technology for our clients. So looking at some of the examples, we create a higher heating efficiency than existing solutions for automotive, seat heaters, and using lower current wool. And we also have a 40% higher antenna performance than conductive ink on TPU for medical and wellness applications. We also get to a scalable manufacturing solution with our manufacturing partner, eSprint, which is a 40-year-old printed electronics manufacturer, and we can create 20,000 units a week or even more, depending on our customers' needs. Looking at our roadmap a little bit, our company was founded by Madison Maxey in 2014, and she was the first Teal Fellow for fashion. And she started this company as a prototyping, proof of concept, and consulting studio for large companies such as Google. And by 2016, she realized that there was a big gap in the industry for scalable e-textile solutions. And she decided to find a way to make this work. And that's when I also joined the team, and together we started working on the R&D of the solution, starting with a conductive ink that Maddie came up with during an Autodesk residency. And by 2017, we were pretty close to the solution that we had right now, and we started doing manufacturing tests with eSprint, which is our manufacturing partner right now. In 2018, we got our first production test, proved that we are scalable, and got FCC certification for one of our products, which is a back heating panel for a jacket. And this year has been an exciting year for us too. We officialized our partnership with eSprint and proved washability with an AETC 135 standards in a washing machine, got 6 customers, and we are planning to do a pilot for one of our customers in Q4 of this year. Next year, in 2020, we're planning to have a CE certification for our product so that we can also sell in Europe. We will have 10 customers, hopefully, and then get to scale production with our pilot customer from this year. And by 2021, we want to expand our team a little bit more and then launch our first product. Talking about the team of LOOMIA a little bit, the leadership consists of Maddie, the founder, and myself. Maddie was, again, a Teal Fellow when she was 18 in fashion, and then she was chosen Forbes 30 under 30, and she is considered an industry thought leader and expert within e-textiles. Myself, I'm the CTO of the company. I have a background in industrial engineering and design and technology, and worked with companies such as Colgate and the Met Museum. We have won several awards for our technology and products over the years, including the Plug and Play People's Choice Award this year, WeWork Creator Awards, and many more. And we have also worked with big companies such as Google, North Face, and Flextronics in the past. Of course, we have a bigger supply chain and network than our smaller team, and that allows us to bring a lot of functionality and solutions to our customers other than just the LEL solution that we provide. This includes engineering and industrial design, soft goods sourcing and production, as well as testing and certification services that we can provide through our large network. We, of course, see that e-textiles can get into any textile application, but we really like to focus on 3 main industries that we think that we can add the highest value to begin with. One of them is automotive interiors and transportation. Second is healthcare and wellness. And third is outdoor accessories and apparel. For automotive interiors and transportation, there are already seat heating applications that we know that we can create a better version of. And we also would like to get into interior lighting, data and power cables, and soft sensors for automotives. For healthcare and wellness, we can also provide data and power cables that can integrate hard sensors, and we can also create soft sensors, therapeutic heating, and textile electrodes. And lastly, for outdoor apparel and accessories, we can create heating for comfort and safety lighting for apparel and accessories that can be foldable and really thin. So why should NASA be interested? we think that our focus areas actually really align with what we can provide for NASA as well. We think that expandable and deployable structures could use our lightweight and flexible technology to create data and power cables, interior lighting, soft sensors, and control surfaces within their structures. And also, we can provide data and power cables, soft sensors, and heating for spacesuits and EMUs. Looking at our market size, we wanted to, again, go even focus further because there's a huge market that we can address, but we would like to address like a smaller portion of it just to begin with. And we focused on automotive seat heaters, interior lighting, and wearable medical devices. Looking only at the automotive portion of the market that we're trying to service, it's like $17.7 billion market, and we think that we can obtain the 53.1 million portion of it. And looking at the healthcare market, which we got a number of 19.21 billion by 2024, we think that we can obtain 57.63 million of it. Our business model mostly relies on our B2B sales, but before we sell anything to our customers, we like to go through a non-recurring engineering period that we call the LOOMIA lab, which can take about 3 months to 1 year, in which we do design and strategy, customization of our layer, design for manufacturability, and testing and certification for the specific product. After that, we start working with eSprint for manufacturing of the product, and then we can sell either a plug-and-play full system or components through those sales, or we can license the technology that we co-created, co-developed with another company that we worked with. Right now, we have an active pipeline that includes over 100 prospects that are in early evaluation phase, 10 or more of which are validated for early projects, and we keep getting 2 to 3 inbound inquiries per week. Some of the more serious prospects that we have, we started doing some preliminary testings with, are about 10 or more companies. And at the LOOMIA lab, we currently have 6 customers, 3 of which are being onboarded at the moment. We are, as I was saying before, planning to get a pilot production with one of our customers by Q4 of this year, and hopefully get to scale production by 2020. Our ask here: we would really like to get more industry collaborations, get project funding, and do collaborations with NASA. Thank you for listening, and I'm happy to answer any questions.
We now have about 15 minutes for questions and answers from the judges.
Can you say something about what the power efficiency is for heat generation?
So when we looked at the existing solutions for car heaters, for example, they were using 12 volts and pulling about 2 amps, and they were reaching to about 150 degrees Fahrenheit with the individual lines. And we are creating a larger surface area that, again, uses 12 volts and pulls about 1.5 amps and gets actually to a higher temperature and can cover a larger area than the existing solution. I don't know if that answers your question, but we basically can design it to work with different power settings for different applications.
How wearable is that? In other words, if you, does it abrade, does it tear?
Oh, sorry?
What's the toughness of the material?
Oh, so again, the insulation is something that we customize for clients as well. Right now, for wearables, we are using a TPU insulation, which is actually pretty comfortable, but is also pretty resistant, and it can be washable, so it's pretty strong.
So building on that, is 50 washes enough? What's your kind of market sense of like why is that the right number?
50 washes is usually what people ask us for. That's why we did 50 washes. We can continue to do more wash testing, but that's the extent we got to with our current funding for that specific test.
What is your current intellectual property strategy And do you have any limitations in terms of licensing from other companies, and do you have any limitations with your current manufacturer?
Of course. Right now, we have 2 patents for our current manufacturing method and technologies, which we also have trade secrets that we have with eSprint. We are not exclusive in manufacturing with our partner, but we try not to manufacture with other partners just to keep like everything kind of close to like a little more secure. But if we develop something with another company that is like a co-development of an IP, we can license it to be manufactured in other facilities as well.
Thank you.
What kind of external temperature ranges can this work within?
Of course. We weren't able to test too much lower temperature settings, so we have done most of our temperature testing in room temperature or a little colder than that, but our materials are supposed to be able to work with like negative 20 degrees.
Can you talk a little bit more about some of your competitors and where you stack up with them?
Of course. Our competitors, I like to not give too much names, but generally it's either conductive ink printed on TPU, which is done by multiple companies, or it's embroidery of conductive fabrics, or knitted conductive fabrics, or some companies that are using actually hard but silicone-covered wires that are like really thin and embedded into garments. Of course, like we do think that there are like a lot of strong competitors, but we do provide a higher value add in certain, like some of the challenges that I mentioned. And also, we can provide to some of our competitors some components that they lack because they only create a portion of the technology and don't have, for example, the soft to hard connection. So we are actually working with some of our competitors to potentially supply to them.
Can you explain more about how your solution technically is different than the other 2 you just described?
Of course. I can talk a little bit about it, not getting too much into detail, but we are, instead of using threads or ink deposition, we are using a conductive mesh that we are patterning with our proprietary method, and then we are changing the insulation depending on what.
So is the mesh almost like a circuit board that then you print on?
Yeah, it's not printing, but yeah, it's like, you can think of it that way, yes.
Cool.
Have you done any vacuum testing? You've talked about the temperature extremes, but
We have not yet. Okay.
Have you done any analysis associated with the kinds of radiation that an astronaut may be exposed to out in outer space?
We have not done any space-related testing, but we would love to work with NASA if there's any collaboration opportunity found to work on some of these tests.
Have you done any testing on other factors besides just tearing, like shock, vibration, or pretty much anything else that can happen to a piece of fabric on a human being very active or running into stuff?
We have like mostly done the testing that were required for other textile applications, such as stretch and strain testing, and yeah, washability testing, color fastness testing, but we have not done like more of the mechanical tests that you're.
Could you elaborate a bit more on the stretching?
Oh,
Like,
stretching.
to how much weight or whatever?
Of course. So our current method on its own is not stretchable, but we can pattern it to be stretchable, and that's actually an ongoing test at the moment. We are getting to up to 5% stretch without getting any damages to the material at the moment, but that's an ongoing test right now. Are there any more questions? Or
Thank you very much.
Thank you.